right? Permutation under restrictions. Like Ganesh Puri. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10-letter word is Ganesh Puri, right? Now, with restrictions, we have to go like first start with G, right? And we have to use all the 10 letters. Second, start with G and ending with I. Third, all the vowels are together. Fourth, no two vowels are together. All the consonants are together, right? 5 question on this. We have already seen how to use the permutation. Now permutation with restrictions. Giving you 3-minute time to think on these questions. Then I'll start In this, the Ganesh Puri, the first condition given is we have to start with G, right? So let's start. Ganesh Puri, right? One, two, three, four, five, six, seven, eight, nine, 10. 2, 3, 4, 5, 6, 7, 8, 9. Right? In this, start with G. If this will start with G, so G must be at first place. And rest of the 9 elements, right? This alphabets 1, 2, 3, 4, 5, 6, 7, 8, 9. 9P9, right? So you are getting factorial 9, or you can say we can start this with 9 option, 8 option, 7, 3, 2, 1, right? That's going for factorial 9, first one. Second, start with G ending with I, right? The same, start with G ending with I. First and last is fixed, and rest 8 will go for 8P8, right? Second one, start and ending with I. All the vowels are together. Ganesh Puri, A, E, U, and I. These four vowels are there, and consonants are N, S, H, P, R. Right. In this case, these four vowels must be together. So we have to take all the four. This is as a one, right? So this is 1, 2, 3, 4, 5, 6, 7. So we have to arrange these seven, right? These 7 letters, right? In how many ways? So 7P7. But these four, A, E, U, and I, can interchange themselves by 4P4. So this is going for all seven. This is going for 7, 6, 5, 4, 3, 2, 1. That's factorial 7. And these four can interchange in factorial 4 ways. Factorial 7 into factorial 4. Right? All the vowels are together. Next, no two vowels are together. Right? So see, G, N, S, H, P, R. 1, 2, 3, 4, 5, 6. Right. 6 consonants are there, right? If I'll write 6 consonants, then 1, 2, 3, 4, 5, 6, 7. 7 places are there. In these 7 places, we have to put 4 A, E, U, I. A, E, U, I. In 4 places, right? A, E, U, I in 4 places. So I can say 7P4, right? These 1, 2, 3, 4, 5, 6, 7, 7 places I have to arrange A, E, U, I, right? So 7P4, but rest of these G, N, S, H, P, and R can interchange themselves by factorial 6 ways. 7P4 into factorial 6. Next is all the consonants are together, right? So G N S H P R A E U I, right? So this is 1, 2, 3, 4, 5, right? So all the way they can arrange themselves in factorial 5 ways, and 1, 2, 3, 4, 5, 6. This will be with factorial 6 ways. Factorial 5 into factorial 6, right? Hope everyone is getting this. How many of you got all correct? Just note down carefully. First case is for starting with G. Second case is for starting and ending with G and I. The fixed positions are there. Third is all the vowels are together. Fourth is no two vowels are together. Fifth, all the consonants are together. All the consonants are together. Again, going for Ganesh Puri. P will be always right of G, right? All the vowels are in increasing order. Increasing order, as this is in the dictionary, means A, E, I, U form. Irrespective where they are, but they must be in increasing order. The first place, right, where the vowels will be started with A, the second place where the vowels will be with E and I, and the last with B, U. U will be always ahead of E, right? Only three. 3 minutes you have to think, then I'll start. First case, P will be always ahead of G. In this case, right, all P will be always right of G, not necessarily consecutively, right? Maybe it can go to 2, 3, and 4 ways. Like if I'm saying ki, right, let this is given, right? In this we have to put G and P. So P will be always right of G. If G is here, then positioning of P will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 into factorial 8, right? But if I'm saying G is here, 1, 2, 3, 4, 5, 6, 7, 8, right? 8 position for, right? 8 position for P, and rest of the alphabet can go with factorial 8 ways. Again, going with G, 1, 2, 3, 4, 5, 6, 7, 7 into factorial 8, and so on. The last will be in this case, when G at this place, P must be there, 1 into factorial 8, right? So we can go with factorial 8 with 1 plus 2 plus 3 up to 9. The formula we know that nn plus 1 by 2. So this I'm getting factorial 8 into 9 into 10 by 2, or we can write factorial 10 by 2, right? So this is the first method what we are doing with this. But let's see, P will be ahead of, first is P will be ahead of G, not necessarily consecutive. Maybe one place ahead, maybe consecutive, maybe 2 places ahead, maybe 8 places ahead, right? So all the cases are there. So we are getting factorial 10 by 2, right? See, the other way how we can think when we have to go for any increasing decreasing method, right? Increasing decreasing way means P is always ahead of G, right? So let ordering of G and P, I'm saying ki let both are some value alpha, right? Both are some value alpha. So Ganesh Puri, just removing G and P, and I'm saying both are alpha. So if I have to arrange these 10 alphabet and 2 alphas are there, so I can say the total number of arrangement will be factorial 10 upon factorial 2. Factorial 2 is for these 2 alpha. So how this is going to be arranged, right? Right, 2 alphas are there, and rest of the elements, rest of the alphabets are going there, right? Something like this. So in this arrangement, now I'm saying like 2 alphas are there. So the alpha right one, I can rewrite this as P, and alpha, the left one, I'm writing this as G. So every time I can fill this to same values to alphas as P and E, and this is only by one ways, right? So only by one ways, right? So first, what we have to do, if we have to go for any increasing or decreasing alphabets, what we have to do, first we have to restrict the arrangement of these two, increasing, decreasing, or three or four, increasing, decreasing order, right? So if I have to, right, diminish the order of any two or three alphabets, so I can assume them as the same one, right? Means they are not arranging between each other. So I'm getting some answer, right? And with the restriction, I know that if I have to write down P, the ahead one, and G, the like coming first or second, right, before one. So this is only one way, right? So this is the second method you can think, right? Third method, careful, Ganesh Puri. Ganesh Puri. We can arrange this Ganesh Puri in factorial 10 ways, but we know that G and P in every arrangement, either G will be ahead of P or P will be ahead of G, right? Only two options are there, means half, in half of the cases, G will be ahead of, P will be ahead of G, and half of the cases, G will be ahead of P. So we are getting exactly what we required in this case. If we'll halve the case of this, so 100% we are getting the answer factorial 10 by factorial 2 or 2 cases. But the best method when we have to use this is, right, first assume all are same, right, reduce their arrangement, and then put the values what they require. Like in the second question, what they are asking, all the vowels are in the increasing order as it is in the dictionary, A, E, I, and U, right? So C, Ganesh Puri. Again, right, Ganesh Puri for A, E, U, and I. These four, I'm saying these four are in this case some alpha, right? Not changing the order, right? So total will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Factorial 10 by factorial 4. So all the arrangements are there with 10 different, right? Right. In between, 4 alphas are there, and rest of the numbers are coming as, and so on, right? So if I can arrange this, so the rightmost alpha, I have to write down A, E, I, and U. The rightmost will be U, before that will be I, and the second from the right will be E, and the first from the right will left will be A, right? So we can arrange this into one ways only. So this is called the increasing and decreasing order, right? Increasing and decreasing order, right? Like in the third one, what they're saying, you will be always ahead of E. Now directly I can say in this, right, 100% I can go for factorial 10 by factorial 2, factorial 10 by 2, right? Anyway, we can do that, right? Now, see this carefully. It's a very, very, very good arrangement of the numbers, right? So please be careful. right? Like if it is question, if it is given, right? Think on this. If I'm asking G and I, G and N must be ahead of P. So what is the answer in this case, right? Write down in chat. Very good. I guess everyone is getting this. Total arrangement is factorial 10, but we have to restrict the arrangement of G and P is factorial 3, but there could be a case when G and N can be interchange each other by factorial 2 ways. So in this case, we are again getting a factorial 2 also. So it depends on the question, what they are asking. If question could be like uh, the order P, G, N, something like this. So the factorial 2 is not required in that case, right? But there are two cases will arise for this if I'm saying P will be ahead of G and N. So maybe N and G or G and N, right? With the numbers, if we have to go like from a three-digit number X, Y, Z with the digits obviously 0 to 9, 0 to 9, such that first question X greater than Y greater than Z. Second question X less than Y less than Z. Third question X greater than or equal to Y greater than or equal to Z, right? All three questions, 3 to 4 minutes you have. Think on this, then we'll go ahead. we have to form, right, in first case, we have to form three-digit number X, Y, and Z, right? If I'm saying ki X is 9, right? If I'm putting X is equal to 9, for the two places Y and Z, right? We have to say we have to select two numbers, right? Two numbers such that one number will be ahead of other. And two numbers, if I have already put one number, just creed values are there, right? All the three are different. So we know that we have already put 9. So we have 8 options. Out of 8, I have to select 2. Plus, if I'm putting 8 at this place, you have 7C2 and so on, last 2C2, right? Or we can say, let's suppose I am selecting 3 numbers, right? 3 numbers, let 10C3. Let any 3 numbers are selected in this case, 5, 2, 7. So now what I'm saying, we have to arrange this 5 to 7 for XYZ such that the largest number will go to 7, the smallest to this will be go to Y, and the smallest will go to Z. So only one arrangement is there. So 10C3 into 1 will be my answer. Hope everyone is getting this. Come again, see. 10C3, I'm selecting 3 numbers, right? Let the numbers are 5, 2, and 7. Now we have to arrange this 5 to 7 according to X, Y, Z. The condition given is X will be greater than Y will be greater than Z. So what I'm proposing for number 7, it has to go to X, number 5 must go to Y, number 2 must go to Z. So we have only one option for that. So 10C3 into 1 will be our arrangements, right? Look into the second one. Second one, the condition is almost same, but the order is different, right? If order is different, then how could we go for that? So in second case, obviously 0 is there, right? And 0 is there if you are selecting 0, right? If we are selecting 0 at any chance you are getting 0, X less than Y less than Z, right? Any chance we are selecting 0, right? So 0 must go to X, then X, Y, Z. If I'm putting 0 to X, this will not be a 3-digit number. This will be a 2-digit number. So this will be wrong. So X must not be equal to 0. If X is not equal to 0, never ever we can put X is equal to 0, means for any 3-digit number, right? Any 3-digit number, right? X less than Y less than Z, right? What we have to do, what we supposed to do is we have to select the numbers from the set 1, 2, 3 to 9 only. Right? X, Y, Z belongs to 1 to 9, not including 0. If not including 0, number of way will be 9C3. Right? Or else you can say you are selecting all the numbers 10C3 minus you can say 0, you can put there. So the number will be 9C2. So again, you are getting 9C3. We know the formula. You have already seen the formula in binomial, right? But the last case, third one, when equality signs are also involved in this. X greater than equal to Y greater than equal to Z. Then in how many ways we can select the numbers, right? So see A, x greater than y greater than z, B, x is equal to y greater than z, C, x greater than y equal to z, D, x is equal to y is equal to z. We have to, right, we have to solve these, right? See, just I'm giving you brief of this again, so you can understand this easily. See, 10C3 is the case when you are taking all the numbers, right? Maybe zero are there or something, right? If you're taking zeros also, right? For this place. Then all the cases when zero is there, you have to subtract. So if I'm putting zero for this case, right, we have two options out of nine, so 9C2 is there. So if I'll subtract 9C2 from 10C3, so that will be the answer for your like non-zero all the numbers at unit place, right? So, but in this case, all are greater than. So you have 1 minute time. Think on this, then we'll go ahead. Okay. See, this is first case, right? Directly we are getting the answer for this is 10C3. This is 10C2 because x and y both are equal, means one number we are selecting for x and y and z is there, right? For this 10C2, for this 10C1. If you'll add 10C1 plus 10C2 plus 10C2 plus 10C3, we know that 10C1 plus 10C2 is, right, 11C2, 11C3, or this will be 12C4, right? The, right, 12C3, right? So directly also, right, directly also you can go for this, right? So one by one you can see like three different questions were there, right? First question, when x greater than y greater than z, so directly you are getting 10C3. Arrangement will be one way, right? X less than y less than z, right? So zero we cannot take, so the answer is 9C3. Without zero, we have to select all the numbers, right? And the third one, when the more than two cases are involved in this, like first case x greater than y greater than z, and second case x is equal to y, and so on. So the arrangement would be something like this. Okay. And directly again, we can get the answer this 12C3, but for that we have to study more on this, right? So this is the arrangement for increasing and decreasing, right? Increasing and decreasing arrangement when we have to arrange. something in the form of increasing and decreasing, right? Now, next we are going for gap method. What is this gap method, right? Like we have already seen key when in between we have to arrange something. With a question we can go ahead, right? Five boys and five girls are sitting in a row in such a way no two boys are together. First question, no two girls are together. Third question, boys and girls are sitting alternatively, right? Boys and girls are sitting alternatively. Okay, see the gap method, right? So no two boys are together, right? So arrangement is 1, 2, 3, 4, 5. This is for girls, right? Five girls are there, right? Now 1, 2, 3, 4, 5, 6. Right? Six gaps are in between the girls, right? If boys has to sit or boys are sitting in between this 1, 2, 3, 4, 5, 6, so 100% we are sure that no two boys will be together, right? Maybe the girls will be together, but no two boys will be together. So how many places are there? 1, 2, 3, 4, 5, 6. 6p5. 6p5 is total number of selection as well as arrangement for the boys, and girls can arrange themselves by factorial 5 ways. So 6p5 into factorial 5 for no two boys are together, right? Second one, no two girls are together, the same thing. First, 5, 1, 2, 3, 4, 5, 6. 6 gaps are there, and again they can go in same way. So 6p5 for girls, and boys can arrange themselves into factorial 5 ways, right? But third question, intentionally I have given this alternatively. Why? Because alternatively is the case when you have to start with girl, boy, girl, boy, girl, boy, girl, boy, right? Or boy, girl, boy, girl, boy, girl, right? So first case is for factorial 5 into factorial 5. Second is for factorial 5 into factorial 5. So we can say this is 2 into factorial 5 into factorial 5. So these three different questions, but in a different way we can solve. Okay. In the same manner, if I'm creating a question, right, this is a beautiful question, what I'm going to give you. A, B, B, C, C, D, E, F, G. We have to arrange these 10 alphabets in such a way, first, no two A's are together. Second, no two A's, B's, and C's are together. No two A's, B's are together. AA and BB are together, but not two C's, right? So you have 4 questions, and again, I'm giving you 3 minutes for this. So think on this, then I'll go ahead, how to think and how to crack this, right? start with the first one. No two A's are together, right? See, first we can start with AA, BB, CC, D, E, F, G, right? So case first, no two A's are together. So what we can do, what we have to do in this case, see, first case without any restrictions is if I'm going to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Factorial 10 by factorial 2, factorial 2, factorial 2. This is the case when we are saying, right, maybe A's are together, maybe B's are together, maybe, right? So without any restriction, we are getting this case, right? Second case, I'm saying when just keeping these two A's are together. If these two A's are together, then this will be counted as 1, 2, 3, 4, 5, 6, 7, 8, 9. Factorial 9 by 2 B's are together, so divided by 2, 2 C's are together, so divided by factorial 2. If I'll subtract both the case, right? So this is the case, no restrictions, right? Restrictions, and this is the case, two A's are together, right? If I'll take the case, no restrictions means two, in this case, two A's are together, A's are not together, both the cases are coming. If I'll subtract this case, so what I'm getting? No two A's are together, right? No two A's are together, right? Two A's are there, two B's are there, two C's are there, and D, E, F, G, right? So first is just we have to subtract from the, like, two A's are together from the complete one, right? Second question, no two A's, B's, and C's are together, right? So, like with the basic set theory, if we'll go, right, this is the universal set, if I'm saying, right, maybe the universal set, right, with the universal set U, A, that this is B's 1, 2 B's, C's 1, 2 C's, right? A's, B's, C's, D, E, F, G, right? Look into this. What is this case? This is the shaded portion. In this case, A's and B's are together, but not two C's, right? If I'll go for this, A's, B's, and C's are together, right? This is the case. A's and C's are together, but not two B's. You have to remember these things, right? In a different type of question, we have to apply the concepts accordingly, right? B's and C's are there, but not two A's, right? And what about this thing? The yellow one, the yellow part. Two A's are together, but not two B's, not two C's, right? So overall, like this is the Venn diagram, right? And we know that the basic formula for Venn diagram for three, and two A's are together, as well as B's are together, as well as C's are together, right? When we have to find all this. A's are together as well as B's are together as well as C's are together, right? So this will be an A means two A's are together, two B's are together, two C's are together, minus n. If I'm writing this thing, A's are together, B's are together, this term is coming twice. So I have to subtract this. And A intersection B, right, minus n A intersection C minus n B intersection C. See, I'm subtracting this term, right, and this term with a different color I'm coming, so it will be easier for you to understand this term and again this term, right? So look into this, right? First we have wrote this NA and B and C, all the terms were there. Then subtracting and A intersection B, B intersection C, and C intersection A. So this one we are subtracting thrice, right? This one we are subtracting thrice means this term is not there, right? So again we have to add the term A intersection B intersection C. So this is the formula for the complete two A's are together or two B's are together or two C's are together, right? And what we require, no two A's are together, no two B's are together, no two C's are together, right? So how to just find this? So this complete, if I'll subtract this, two A's are together or B's are together or C's are together. So this whole portion outside will be coming for an A intersection B in A union B union C. So the whole outside portion is giving you, right, A's are not together, B's are not together, and C's are not together, right? This is called the universal U, right? So case second is no two A's are together, B's are together, and C's are together, right? So A, B, C, D, E, F, G. Right? If I'm writing with the complete, two A's are together, right? Two B's are together, two C's are together, right? So how many of these are possible, right? So total is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Factorial 10 by factorial 2, factorial 2, factorial 2. Minus two A's are together. So this two A's are together. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Factorial 9 by factorial 2, factorial 2. The same case will be for B. Same case will be for C. And for different, right? 1, 2, 3, 4, 5, 6, 7. Factorial 7 is for, right, all the cases. So this is the case. Either two A's are together or B's are together or C's are together, right? All the union cases are there, right? Right. This is for two A's are together, two B's are together, two C's are together. And this is the case for when we are saying all the threes are together. And if I'm subtracting this with the complete set, right? Complete set, like all the cases when we are taking the cases when A's are together or B's are together or C's are together or not together also. And we are subtracting all the cases of togetherness. So what we are getting with the full of this will give you the answer for no two combination will be together with the set theory only, right? Third one, A's are together, B's are together, but A's are together, B's are together, right? So this is the case, what we want to, right? So A must be together, B must be together, C, D, E, F, G. There isn't any restriction with C. So 1, 2, 3, 4, 5, 6, 7, 8. factorial 8 by factorial 2, A's as well as B's are together, but not two C's, or maybe two C's, right? Fourth case, A and B are together, but not two C's. Same case with, right? If in this case, A's are together, B's are together, and there are two cases, C's are together and C's are not together, right? So if I'll subtract two C's are together again, so 1, 2, 3, 4, 5, 6, 7, factorial 7. So what I'm getting there, right? From total, I'm subtracting this, so I'm getting an answer for this. So no two C's are together. So carefully, if I'm able to do that, right, one by one, where we have to subtract, that we can see, so 100% you'll get the answer in, right, simplest form, right? So this is very, very, very important set theory method, right? You have to remember this, and obviously we have to apply this also. Right? So one question just for practice I'm giving you, success. We have to arrange success first. Two C's are together, but no two S are together. B, no two C's and no two S are together. Right? Maximum 3 minutes you have. Think, then I'll go for. The best way to solve these type of question is the gap method. Already we have seen. Success 3S are there, and U, CC to C must be together, and E, right? So if I'm writing U, CC, and E, then we have gaps 1, 2, 3, 4, right? In 4 gaps, we have to select 3 gaps, and the S is coming there, all the S are same, so only one way. But 1, 2, 3, these 3 can interchange in factorial 3 ways, right? This is the answer for first one. No 2 S are together, but 2 C's are together, right? 2 C's are together. Okay, now the second part, when we have to see no two C's are together also. If I'll go for U, C, C, and E. So we have how many gaps? 1, 2, 3, 4, 5. 5 gaps we have, right? So 5 gaps I can fill with 3S. So 5C3 into 1, 2, 3, 4. There's factorial 4 by factorial 2, right? This is going, but there is a problem with this case. What is the problem? Look, the problem with this case is I'm saying ki 1, 2, 3, 4, 5 gaps are there, and we have to only fill 3. If I'm filling 1, 2, and 3, so 2 C's are coming together, right? So in this case, 5C3 into factorial 4 by factorial 2, I have to subtract all those cases that C's are coming together, right? So just this is 5C3 factorial 5 by factorial 3 factorial 2 into factorial 4 by 2, right? 5 into 4, 10, 12, 120 minus this is 24. So I'm getting 96 as no two C's, no two S are together, right? No two C's, no two S are together in this case, right? Like one more question, and it's a very, very important. 10 students are sitting in a row in such a way, 10 students are sitting in a row. We have to select 3 students such that no two are consecutive, right? No two are consecutive means 1, 2, 3 up to S10. 10 students are sitting there. You have to select 3 students, right, from anywhere. No two are consecutive. In how many ways we can go for this? See, 10 students are sitting in a row. We have to select 3 students, and in such a way, no two are consecutive, right? No two students are consecutive, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 students are there. So let's suppose what I'm doing, right? These 3 students are like S1, S4, or S7. Except these 3 students, I'm putting all the students in a row, right? So S2, S3, S5, S6, S8, S9, S10. So all the other students are sitting in a row. So we have 1, 2, 3, 4, 5, 6, 7, 8, 8 gaps, right? In these 8 gaps, if these 3 students are sitting anywhere, then no two will be consecutive in S1, S3, S1, S4, and S7. So every time I can say in the reverse way, I can say this, if we have to select the students, no two are consecutive. So what we can do, we have 8 gaps in between, right? So in 8 gaps, if I'll select 3 of them, right? And they are sitting there in factorial 3 ways, and rest of the students can sit in factorial 8 ways, right? No 3 student will be consecutive, right? No 2 student will be consecutive out of what we are selecting in the group, right? So you can say like 3 students were not that we have to choose. Let we have already chosen them, right? And let the left students are there is 1, 2, 3, 4, 5, 6, and 7. So if we have to arrange these 3 students into the row in such a way, no two are consecutive. We have 1, 2, 3, 4, 5, 6, 7, 8 gaps, right? So 8C3 will be the gaps, right? But 3 different students are there, so they can sit in factorial 3 ways, and 7 students are there. This will be 7. 7 students are there. So factorial 7 will be the ways the rest of the student can sit in the row, right? So just we can see like how we are going to just select the number of students, or like 3 students are not consecutive to each other, right? This in this question I'm saying no two are consecutive. Maybe the question will be all 3 are consecutive. That will be easier one. If all 3 are not consecutive, it is given, so obviously you have to count 1, 2, 3 up to n minus 2, n minus 1, and n, right? So total number of arrangement will be, right, n, right? And in this case, the selection process was 8C3, but all the 3 different students can sit in factorial 3 ways, right? And 7 students, these 7 students can sit, right? These 7 students can sit in factorial 7 ways, right? And these 3 students can sit, right, in factorial 3 ways. That's the reason 1 factorial 3 and 1 factorial 7 is coming on this. And only if the question is asking for only the arrangement, like how many ways we can select this, so that will be 8C3 only, right? So overall, like you'll get the answer in simplest form, right? So There are 8 stations in a row. We have to select 3 stations such that no two are next to each other, right? Out of 8, we have to select 3. Okay. Right. So directly we'll get the answer. Obviously, only 5 stations I'm putting there, right? 3 stations, what we have to select, we are putting in the gaps 1, 2, 3, 4, 5, 6, right? 6, P3, right? And in this, we have not to arrange this, right? The stations are there only, right? 6C3. Right? Because the stations are fixed, right? Only we have to select. So in how many ways we can select? The students we can arrange in between, but we have to select 3 stations out of 8 in such a way no two are consecutive, right? So I guess all you are getting what we are doing. First, we will take out all those cases when no two stations are consecutive. Then rest of the 1, 2, 3, 4, 5 stations are there, and all the cases are the same case when we are just putting back the 3 stations in between the gaps, right? So how many gaps are there? 1, 2, 3, 4, 5, 6. In these 6 gaps we have to select 3. So in this 6C3 we are selecting 3, and right, obviously no two will be consecutive in this case. Hope everyone is getting this. This is one of the elegant method, one of the simplest method what we are doing. Otherwise, that could be go in a very nasty way that we have to solve by different way, right? So this is the gap method, what you have to do, right? The next we are going to do is combination under restrictions. Combination under restrictions, like what we have to do, like with a question we can go, right? The question I'm just putting for this, how many different selection of 6 books can be made from 11 books if, case first, 2 particular books are always selected, right? Second, 2 particular books never selected. It's a very simple question, right? Right. See, like in this case, it's given that the books are into the number B1, B2, B3, B4 up to B8 and B11, right? 2 particular books, let's suppose this is B1 and B2, right? First case, what is the question? 2 particular books are always selected and we have to select 6 books, right? Out of 11. So total is 11, we have to select 6 and 2 books has to come, right? I'm saying we have already selected these 2 books, right? B1, B2 are selected there. So now we have to select only 4 books out of 9, right? So first is 9C4. If B1 and B2 are fixed, that has to select in the question, right? Second question, not selected. So again, B1 and B2 removed from there, and this is 9C6. Out of 9, you have to select 6, right? The simplest way with the restrictions, we have to, right? We have to fix this. Either we have to select or reject this. Okay. There are 10 switches. This is the switchboard and 10 switches are there. These 10 switches are such that this connected to the 10 different bulbs, right? 10 different bulbs, this is connected, right? And these bulbs are in a hall, right? So in how many ways we can illuminate the room by switch on the lights? The restrictions, right? We have to illuminate the room, right? In how many ways we can illuminate the room by switch on the lights? Right? So, very good. So we can start with, right? We have 10 switches, so we can start with, so we can illuminate the room by switching one only, or we can go for 2 only or 3 only up to 10 only. This is the first way you can think. Or the second way we can think, this switch have 2 options, either this will be on or off, right? So 2 option for this, second for 2 option, third for 2 option, 10th for 2 option, right? But one of the option where all the lights are switched off is 1. So this will be 2 to the power 10 minus 1. So either you can go by first one or second method, right? Right? There are 10 matches, right? And the result are only win or loss. In how many ways we can predict the result of all the 10 matches? We have to predict the result of 10 matches, right? In how many ways we can predict this? See, for first, we have two options, win or loss. Second, we have two options. Third, we have two options. The 10th, we have two options. So every time you are getting two options for first case, two for second, two for third, two for 10. So this will be 2 to the power 10, right? Now, if I'm including one more there, right, win, loss, or draw, in how many ways we can go for this? Total number of prediction for matches. So every time you are getting three options for 10 times, so this will be 3 to the power 10, right? Hope everyone is getting this. Like a set is given, set A, that contains n elements, right? How many subsets are possible, right? How many subsets are possible? What is the nature of subsets? First is the null set, means you are selecting with 0 for 1, 2, up to n. So this will be 2 to the power n, right? 2 to the power n, total number of subset in this case. Subset means like the elements are 1, 2, 3, 4, 5. So we are saying ki like subsets are, first is a 5, second is a singleton set, right? Then pair of elements you are taking, then 3 numbers, 4 number, 5 number. So first you are saying ki NC not, you are not taking any number with one element. How many subsets are possible with 2 numbers, with 3 number, with n numbers, right? Or we can see this, that any element AI is there, right? If we are making a subset, let P, right? The property of P for AI will be either AI will go to P or AI is not going to P. For any element, we have two options, right? N elements are there. Total number of options will be 2 to the power n. The simplest way to crack this. Okay,